Welcome back. This module is probably not going to be the most exciting of the bunch, and I apologize in advance for that, but it is important to get some of this groundwork out of the way so that we can have a real conversation about game design. I'll try to get to the interesting bits as fast as I can, promise.
So, with just about any course of study, one of the first questions we ask is, what is this thing we're studying? What does it even mean? How do we define it? And a lot of times this actual definition is elusive. Like, if you're taking a biology class and trying to define what is life, you realize it's actually kind of hard to do that. And there are a lot of weird edge cases. And at some point you have to accept that we don't really have a great formal definition and we move on. And it turns out game design is kind of like that too. Here are a few examples of definitions of games that have been proposed by people way smarter than me. That last one at the bottom is from a book called Rules of Play that helpfully includes all of the others. So thanks to Katie Salen and Eric Zimmerman for doing that work for me. I'm not going to go into each of these individually, and the reason for that is, well, every single one of them is flawed. Some of them exclude things that are very clearly games. Some of them include things that are clearly not games. Some of them do both. It turns out there are just a lot of weird edge cases with games that tend to trip up every definition. Like tabletop role-playing games like Dungeons & Dragons or MMORPGs like World of Warcraft, for example, are things that most people would recognize as games, but neither one has an explicit goal or an end state or the ability to win or lose, and those are things that show up in a lot of definitions. Sim games like SimCity and The Sims also don't have goals, and they also don't have real clear opposition either. Will Wright, the designer of both of those games, even said that SimCity wasn't a game, it was a software toy. But at the time, if you were in a large department store and wanted to buy a copy, you'd probably look in the video games department and not the toy department. So most people would seem to recognize those as games, even if the creator says otherwise. Lots of children's games like Snakes and Ladders and Candyland offer no decisions at all. The game pretty much plays itself, which excludes those from any definition that requires decision-making. But again, most people would still recognize them as games. And while most game designers go through a phase where they think they'll be the clever one that finally finds the perfect answer, don't feel bad if you can't. At some point, you'll want to give up on this and move on and get to actually making games. Now, on the bright side, to an extent, it doesn't matter. Even without a strict formal definition, most of us still recognize what is and isn't a game, and we intuitively know it when we see it, even if we can't formally define it. And if we try to exclude something by saying like, oh, well, that's not a real game, that's really just gatekeeping. It's generally not useful for game designers. So ultimately, my definition is that a game is what we all kind of collectively say a game is. We can afford to be pretty broadly inclusive here, and while strict definitions might be important in places like courts of law, where we have to decide whether certain game-related laws apply to specific products, it's not a problem that we really have to urgently solve in the field of game design itself. So we're going to move on from that. So okay, if we can't define game, we'll probably have a hard time defining video game, right? Actually, this one's pretty straightforward. It's a game that's played on a video screen. Sure, there might be some weird questions about what exactly counts as a screen, but if you accept the game part isn't defined, the video part is relatively easier. Okay, let's move on. Play. I bring up this other word that's also really hard to define, because play and games are related. We say that we play a game. Games are a play activity, so it's worth mentioning play as well. There's a bit of a paradox here, because it turns out they're both kind of a subset of the other. Games are a subset of play in the sense that there are many types of play activities. Some of those are games, some are not. For example, when little kids play dress up, or play house, or play pretend, we would call these play activities, but we usually wouldn't call them games. So the space of play is larger than that of games. Games are just one way to play. On the other hand, inside of a game itself, there are many parts of a game. There's the physical components for board games, the code for video games, the rules, setup and cleanup. Play is part of the game experience, but is not the entire experience. So in that sense, the play of a game is really just one part of the game. I can't really resolve this paradox for you here. Just keep in mind that play and game are highly related concepts. Both are kind of hard to define. So enough definitions for now. Let's take a break by actually playing a game. I'm going to teach you a game that you have probably not seen before. It's called 3 to 15. This is a 2-player game, so obviously this is a non-interactive video. I can't exactly play with you, but I can teach you to play, and you can either play against yourself by controlling both players, or find another human to play against and try it. So here's how this game works. The game is played in turns between exactly 2 players. Randomly choose a player to go first. That player then chooses one of the whole numbers between 1 and 9. That number is now theirs, they own that number, and neither they nor their opponent can choose that same number again. Let's suppose that our first player starts off by choosing the number 6. Now it's the opponent's turn, and they can choose one of the remaining numbers. The goal is to eventually collect some set of exactly 3 numbers that all total 15 when added together. That's why the game is called 3 to 15. Let's say our second player here chooses the number 7. Now the first player takes another turn, and it keeps going back and forth like this until someone wins, or until the numbers run out with no one winning, in which case it's a tie. So from this position, let's suppose our first player chooses the number 1. Now the second player realizes that the first player has a 6 and a 1, and if they took an 8, they would win, because 6 plus 1 plus 8 is 15. So player 2 would do well to choose the 8 instead. Now, 7 plus 8 also equals 15, but remember, you need 3 numbers to total 15, not 2. The name of the game is not 2 to 15, so the second player does not win immediately, at least not yet. It's the first player's turn again. Let's say this time they choose the number 5. Now, the second player recognizes that if the first player chooses the number 4, 6 plus 5 plus 4 will equal 15, so the second player chooses the number 4 instead. However, what the second player might not have realized is that the first player has another path to victory. 1 plus 5 plus 9 also equals 15. The first player chooses the 9 and wins in this example playthrough. If you don't recognize the game yet and have someone you can play it with, please pause this video now, explain the rules, play with them. Or play on your own. Play as player 1 and player 2 back and forth and try to kind of beat yourself and get a sense of the strategy. You can play on paper, or just keeping track of the numbers on a computer, or even in your own head. So go ahead and pause the video, play the game a few times, and unpause when you're done. Okay, so did you finish playing? Have you recognized this game yet? If you haven't, I'll just warn you, I'm about to spoil it for you, because it turns out you probably have played this game before, or at least something like it, just in a slightly different form. Now this 3x3 grid with the numbers 1 through 9 in it is what's called a magic square. It has a property that every row, every column, and both diagonals all sum to the same number. In this case, that number is 15. Now do you recognize the game? Just to be absolutely clear, let's change the game so that instead of selecting a number, the first player marks the square that they claim with a symbol. Let's say the letter X, and the second player uses a different symbol, say the letter O. Here's how that sample game we played looks on the grid. So in our sample game, the X started play in the top left corner, and then O played in the top center. X responded by playing center left, and O took the bottom left to block. X then took the center square, opening both the downward diagonal and the center row as potentially winning moves. O blocked the diagonal by placing in the lower right, and X took the center right for the win. The only thing I could do beyond this would be to redraw the game board as a hashtag rather than 9 squares. You probably recognize this by now. Depending on where you live, this game has many names. I grew up learning it as tic-tac-toe. Others call it X's and O's, or noughts and crosses, or several other names. But here's a question to think about. Is this game the same as 3 to 15, or are they different games? Well, in order to answer that question, just using the word game isn't really sufficient here. We need better words to describe the parts of games in order to answer this question, because there are clearly some parts between these two games that are identical, and other parts are not. So let's break games down into their component parts. Okay, so the first part I want to talk about is players. Technically, players aren't part of a game. If you buy a game in a box at a game store, it doesn't have players in there, but players are part of the experience of play. They are a very important thing that designers have to keep in mind when designing games. And there are many different relationships between players that you can design for. You can have solo games, direct competition between one or more players in various ways, to cooperative games where players team up against the game. I've shown a few common player-player relationships here, but there are a lot of others that I'm not showing. When designing a game, you want to be thinking about how many players there are and what their relationships are with each other. Who is a friend, who is a foe, and can the nature of those relationships change over the course of the game, or is it fixed? Next is goals. Not all games have goals, but most do. You might see some game designers even go so far as to say that this is the difference between games and toys. A ball is a toy, you can play with it and you can do things with it like bounce it or throw it, but a ball isn't a game until you add some rules and a goal. Be the first one to get the ball into a hoop. Now you're playing a game. Now, there are plenty of games that have no inherent goals. We might even sometimes see them referred to as software toys or interactive playthings, and a common piece of advice you'll hear from game designers is build the toy first. That is, focus on the part of your game that's just fun to play with, even without any goals or rules. Just get the core interactions to be fun, even when there's no goal. And if you can put some squares on a screen and have them moving around in a way that just inherently is satisfying on its own before you even implement something like win and loss conditions, then once you add some rules, it'll probably continue to be fun. That said, most games do have goals, and when explaining the rules to a new board game, for example, I usually start with what the object of the game is. How do you win? Because that's the most important thing for new players to figure out. And when I'm consulting with designers or teaching students about game design and they're having trouble where they're stuck with a game idea and they don't know where to go next, I found one of the most useful things to do is start asking a fundamental question of, what is the goal of this game again? What is the player trying to do? And that'll often get people unstuck. If you're struggling with coming up with an idea for a game or fleshing out that idea into a full game, chances are good that part of that struggle might come from you not having a clearly defined goal for the player. And there are lots of kinds of goals. I've put some of them here. So you could have goals like, capture or destroy, like in chess or Stratego, control territory, like in Risk, collect things, like Rummy, solve something, like in Cluedo, race or chase or escape, like in Mario Kart, spatial alignment, like Tic-Tac-Toe or Bejeweled or Candy Crush, to build, like in the board game Catan or in SimCity or City Skylines. Negate another goal or to eliminate other players. Think of Twister or Jenga. Or you could have a goal that's a combination of other goals. Another part of a game is a game state. So game developers sometimes refer to the game state when discussing games, and this is basically defined as all the information you would need to take a snapshot of a game in the middle of play at a single point in time and be able to recreate it completely. For video games, the game state is literally what gets saved to the disk when you save your game, if you were saving in a way that loading would bring you to exactly the same spot. The game state of 3 to 15 includes which numbers have been taken by which player and also whose turn it is, or at least who went first. Another term you'll hear a lot from game designers is game mechanic. Sometimes this is used interchangeably with rules. Sometimes a designer will insist that rules and mechanics are related but distinct concepts. Ask 10 different designers to define exactly what a mechanic is, and they'll fight over it. There is no industry standard accepted definition, but we do use the term mechanic and generally understand it and use it in the same way anyway. For me, and again, other designers might disagree with me on this, I think of game mechanics as anything that causes the game state to change. So that includes things that are under player control, like the ability to move or attack, but also things that happen automatically in the game, like a time limit that causes something to happen when time runs out, even if players are doing nothing. The mechanics of the game are probably what you'll spend most of your time designing early on, and one of the first things you'll want to get working well to the point that they're fun before you build too much content. Sometimes designers will talk about the core mechanic of the game. When we talk about the core, that is the mechanic that is repeated over and over on a moment-to-moment basis, every few seconds. In a first-person shooter, the core mechanics are moving, aiming, and shooting. In a side-scrolling platformer, the core mechanic is jump. Since the core mechanic is the thing that happens the most, that's the most important thing to get right in terms of its impact on the overall play experience. Another common piece of advice is that every other element of the game should support the core mechanic. If you've got something that's fun for the player to do, all of the goals, all of the other mechanics, all of the interactions should be encouraging the player to engage with that thing. Likewise, if your core mechanic isn't fun, no amount of extra content or systems layered on top is going to make it fun. You'll have a game with a few nice moments that the player feels like they need to drag themselves through everything else just to get to the isolated fun bits. So early on, you want to identify what your core mechanic is, and if you have questions like, should I include this feature or not, just ask, how does it interact with the game's core? Does it support it, or does it take away from it?
This module is in multiple parts. Thanks for watching this part, and I'll see you in the next part, where we'll learn more about this topic in this module.